Hello everyone. In this video we're going to be solving a Diophantine equation and we're going to be looking for rational solutions. Instead of integer solutions, we're going to look for rational solutions this time. So let's get started. Now we do have x cubed plus y cubed is equal to x squared plus y squared. So let me go ahead and write that down now so that everybody knows we're looking for rational solutions. Okay, now how do we go about solving this problem? Well, you probably noticed that the same powers appear on the same side. So we're going to be using some interesting strategies that we use with homogeneous equations. All right, cool. Let's go ahead and look at some special cases first, though, to exclude those from our calculations, because those are very special and we can just go ahead and talk about them real quick. So, for example, if x is equal to 0, right? If x is equal to 0, then we have two possibilities, obviously. From here, we get y cubed is equal to y squared. And if you go ahead and factor out, like put everything on the same side, y cubed minus y squared is equal to 0. And if you pull out a y squared, you're going to get y minus 1, which means that y can either be 0 or 1. So for x equals 0, we have y equals 0, y equals 1. Obviously, 0, 0 is a solution. So in our calculations, we're going to just ignore that part, because we already covered it, right? Cool. Now, what are we going to do? Well, since this equation is somewhat homogeneous, or I guess we could call it homogeneous, we can go ahead and do the following. And that's actually a really nice strategy for these types of equations. You can use that and apply it to many different situations. So we're going to assume that y over x is constant. And you're going to see why that works. So basically, I'm just assuming that, okay, what if y over x is equal to k? All right, cool. Now, in this case, you got to be careful because x does not equal 0, y does not equal 0. We want to avoid those cases. That's why we looked at those first. So this will be defined all the time, right? If x and y are not equal to 0. Now, from here, we basically get y equals kx, where k is a constant. As you know, this is the equation for direct variation, so on and so forth. Very common applications of this. Now, let's go ahead and substitute kx on both sides for y. So this is going to give us, let's see what that gives us. Okay. X cubed, we have x cubed, and then plus y cubed. So I'm going to replace y with kx cubed. And then on the right-hand side, I have x squared plus the quantity kx squared. All right, let's go ahead and expand this a little bit and simplify. This is going to be x cubed plus k cubed, x cubed is equal to x squared plus k squared, x squared. Great. Now, one of the things we can do is, and that's why we actually use this method, and that's why it works, is we're able to factor out an x cubed so that we can have k as a parameter. So we can pull out an x cubed here, and then we're going to have 1 plus k cubed. And same thing on the right-hand side, we can pull out x squared and end up with 1 plus k squared. Beautiful. Now, we know that x does not equal 0. I think I should also write that down. Suppose x does not equal 0 and y does not equal 0. Okay? Now what happens if you look at this equation? So one of the things that you might be thinking about is, can k equal -1? And the reason why I said that is going to be actually clear in a little bit, but notice that if you replace k with -1, on the left-hand side you get a 0, but on the right-hand side you don't necessarily get a 0 because 1 plus k squared is always positive. So we also have to exclude that case, but what is that supposed to mean? Well, if you look at our original problem, you're going to understand what I'm talking about. Obviously, if this is equal to 0, x cubed plus y cubed, that means that y is equal to -x, right? But on the right-hand side, notice that x squared and y squared are both non-negative. They're not going to be 0 unless x and y are both 0. Cool? Makes sense? So in this assumption where we said x and y are not equal to 0, we can safely say that y does not equal -x because x plus y is not going to be 0. Therefore, or this implies that k does not equal -1. This is also an important exception because that causes some problems and we want to exclude that. So having said that, let's go ahead and solve for x and then for y. Obviously, we want to solve for x and y. And remember, we're looking for rational solutions. So in order to solve, first of all, notice that x cannot equal 0. So that means I can basically divide both sides by x squared, right? That's non-zero. And that gives me x times 1 plus k cubed is equal to 1 plus k squared. So we got rid of all the x's pretty much except for 1, because of course you want to save it. And then divide both sides by 1 plus k cubed, and you're going to be getting the solution for x. So, you can write it this way, kind of like put it in a more standard formish, like this, as a polynomial. So x can be written as k squared plus 1 divided by k cubed plus 1. Obviously, in this case, k is not going to be equal to -1, so we're not going to have an undefined expression. Okay, cool. So now we have a value for x, but what about y, right? Well, remember when we started the substitution, we assumed that y can be written as k times x. So since we have a value for x, we can just go ahead and multiply this by k to get the value for y. All right? So if you go ahead and multiply this by k, that's going to look like k cubed plus k divided by k cubed plus 1. Okay, great. So this basically brings us to the end of this video. What is that supposed to mean though? Well, this means that if you replace k with any number, and it doesn't have to be an integer, by the way, but if you replace k as with any rational numbers, then you're basically going to be getting some solutions. You can even replace k with 0, right? Wouldn't you? Like if you replace k with 0, for example, you're going to be getting 1 for x and 2 for y, right? Well, actually, both of them are going to be 1. Is that right? Okay, you can just test it out. You replace k with 0, replace k with 1, and then so on and so forth. But if you just do replace k with 0, you're going to notice that y is going to be 0, but we already excluded that case. So these are going to give us all the solutions in parametric form, which means you can basically change the values of k. And for every value of k, you're going to be getting an ordered pair, which is a solution of this Diophantine equation. All right, this brings us to the end of this video. I hope you enjoyed it. Please let me know. Like, comment, and subscribe. I'll see you tomorrow with another video at the same time on this channel. Take care. Bye-bye.